Good afternoon, students. Today we will be discussing regarding our lessons in Arduino, specifically input, outputs, and timers. So today, as you can see here in your screen, that there is a demonstration of uh, an RGB LED, a blinking light, which is just an RGB LED. So today we'll be demonstrating about the pin modes, what inputs and outputs are, how they are going to function in regards uh, to our Arduino right now. So first off, let us define what I/O is. I/O simply is a shortcut of the word input output. So input output for Arduino, inputs and outputs are something that is essential for Arduino to function correctly. So Arduino needs inputs in order to execute its task. Meanwhile, it also generates outputs to allow it to be functional. So, so let's start off. So, if you don't have Arduino with you, I would like you to pull up your Tinkercad and we will be starting our design with a new one, just for demonstration purposes. I actually have Arduino here with me, as you can see here in our screen at the moment. Um, any kind of LED will suffice. In my demonstration, I am using an RGB LED, which is just three colors of LED combined into a single bulb, in which uh, you can easily achieve with three differently colored bulbs. So, I will try to insert Arduino here. So, if we observe Arduino, there are several pins. We have already discussed in our previous lesson what the purpose of these pins are. But here in the digital segment of the pins, which allows it to be able to receive or output data. So, digital pins allow us for any kind of purpose in it, specifically input and output. Uh, the tilde mark pins specifically allows for analogous simulation through pulse width modulation, meaning recreate how um, it can try to recreate analog signals. Meanwhile, in the left side, in the bottom left of our Arduino, we also have analog inputs. Analog inputs are um, ways in which it can receive signals that are beyond the reach of digital signals. Most of the time, when we refer to digital signals, it can easily be decoded as uh, ones or zeros. That's how digital signal is. It could either be one or zero. But it is quite different when we uh, mention analog signals. Analog signals can be 1.25, 2.7, even negative values. So that's how analog input is. So we have several examples of analog uh, analog inputs here or analog senses here. So let me just demonstrate. This one is a typical button in which it can be simulated with a digital signal. When a button is pressed, a digital signal of 1 or high is being sent. But this is a joystick. Unlike uh, the button pad that I have exhibited earlier, um, a joystick can actually create analogous signals due to its um, difference in position. So most directional pads, which is either up or down, left or right, or a combination of those, can actually be simulated with digital signals. But this one, in which there are precise positioning in the buttons that allow it to be sent as an analogous signal. Another example would be RFID. So, radio frequency is sent through analogous signals. This kind of technologies are often used in radio technology such as credit cards, SIM cards, even RFID tags in your IDs or used as identification for vehicles. This also appears on your phone. This is also present in your phone. So there are several types of analogous signal or analogous devices out there. Now, we will be demonstrating how analog analog and digital is being or analog or digital signals are being output via our uh, Arduino Uno. So here in my demonstration, uh, though I am using an RGB LED because it is easier to simulate different colors that way, we will be recreating what I did with the Arduino here. So I added an Arduino Uno. Let's just use a small breadboard for this. Let's try recreating the simple blinking ones here. As you can see in my code, this is just digital, right? But we will be changing it to an analogous signal. So to recreate this, we will be needing either three kinds of LED bulbs with differing colors, preferably red, green, and blue. So let's just add one. Then this one should be green, and another one should be blue. Or you make use of an RGB LED bulb, similar to what I have used in my demonstration. So let's just search for RGB LED. So there's a LED RGB. You can use either of this. If this is present in your toolbox or in your toolkit for Arduino, if you have one, you may make use of this. We also have different kinds of LEDs. For example, here is something I bought from uh, AliExpress. This is a 5-volt RGB LED strip that I intend to use for my computer. But this is actually functional with your Arduino Unos. So as you can see, there are, let me zoom this in through my phone. As you can see, let me focus this. Okay. So you will notice that there are several bulbs in there, LED bulbs that are capable of outputting three different colors. So let me just skip this. So for each LED bulb, we will be needing three resistors. Also same for the RGB LED bulb. Because it is governed by three colors, each of these colors makes use of one resistor. So we will be needing resistors, specifically 220 ohm. You can easily buy one in most electronic shops, especially there in uh, Uyangurin. You can buy bulk. So we will be needing three of this. Okay. So we will be starting off with adding the bulb. So, okay, let's start with red, then green and blue. Then we will be using, okay, this one. Then we will be adding wires. So let's just rotate our Arduino. This one, to rotate the Arduino, you will be using the button R. Click on the Arduino, then press R. So we will be connecting the ground wire to this whole lane here. Then it's colored as black. Now, we will assign um, 7, 6, and 5 for this. So let's just assign this 7, 6, and 5. To make it easier for you to discern the differences, we can change the color according to the LED that they are using. Let's just try this, and this one should be blue. Okay. Now, we should be able to manipulate each color by individually. So, first, let's go to code.
Sir, nasa Tinkercad ka, sir?
Yes.
Ayun, meron din, sir.
Okay.
Meron. Kanina wala.
Okay. Try to replicate this on your Tinkercad. You will be needing three bulbs, three LED bulbs, which is red, green, or blue. We will be reserving RGB LED for later. Again, three LED bulbs. The anode should be connected to uh, each of the bulbs should have resistors connected to the ground, while each of the bulbs should have its wiring connected to 6, 7, 6, and 5. Okay, I will be setting this aside. I will just be moving this here a bit so that you can see it. But this black wire is any pin here in this ground lane. So I will just be moving it here so that you can see it. Then let me open code. So here from this panel, I want you to change the blocks to text. So now you will see something different. Notice something different from uh, the blocks. You're noticing that this is not so as simple. As you will notice here from the left side, this is what we call the Arduino IDE, or Integrated Development Environment, in which you are able to code a program for the Arduino. Here in Tinkercad, this is just a simulation of the Arduino IDE, but we should be able to recreate what we are intending to do with these LED bulbs. So these LED bulbs should light up later if our uh, if we did everything correctly. So let's remove, or rather let's add or declare three integers above void setup. So first one, we will be declaring an integer name pin red, then int pin blue, and int, or rather let's just do this in order, green and pin blue. Then assign values to it depending on the pin in which it is assigned. For example, for the red LED, we assigned it 5. So the value for red should be 5. Then 6 for the green one, and 7 for the blue LED. Then we are going to initialize the pins 7, 6, and 5 so that we will be able to use it for the looping. So here, we will just copy this and modify the pin mode. So we will be using this pin mode and replace this with the pins that we are using. So pin red, pin green, and pin blue. Now, we want it to blink simultaneously. We want it to blink together, blink in and blink out. So to do this, we need to simply add this line of code, digital write. Again, when we say digital write is only able to output two types of values. It is either on or off, 1 or 0, high or low. So for this one, we will be changing the value to pin red and copy paste this for the uh, other pins. So we will be doing this for the other pins as well, green as well as blue. Maybe change the delay to 500 milliseconds. You will notice there is a delay here. This is denoted by the number of milliseconds. So when we say 1000 here, it means 1000 milliseconds or 1 second. So we will be changing this to 500 or half a second. Let's copy this. High meaning we are turning the LED bulbs on. Then paste this again and we will be changing the value to low, meaning we are turning the LED bulbs off. So I hope everybody managed to catch up. So we will be trying to simulate the code now. And hopefully everything runs smoothly. So as you might notice that it is not turning on. So anybody here, anybody from the students should be able to identify what the error is with regarding the code. Daryl, are you able to identify what is the wrong in this code or in this uh, pin configuration?
Wait lang sir. Check ko lang yung code. Pati saan nakakonect. Pwede paki-zoom sa may Arduino na part sir.
Okay.
Ay,
What do you think is wrong?
sa ano sir? Sa output na part? Sa may code? Tama ba?
Mhm.
Since tama man na high, naka-high, then low, then spelling tama, then
Okay.
under.
Thank you for your input, Daryl. We will be checking what is wrong with this one. So, diodes, specifically LED and other types of diodes, are very particular in the direction of the current. Diodes only accept currents or electricity one way. Meaning, if you oriented your wires wrong, it will not turn on. So, let's try switching up the wires. So, let's try inverting it. Let's try inverting it. So, as you notice, the bulb is already turning on. So, again, light emitting diodes and other diodes only let electricity flow through in one direction. So now that we have corrected our error, we will be using analog write. So we will be using analog write, and for this, we will be using the RGB LED that we have prepared here. Again, RGB LED functions similarly to the three bulbs here. It is basically a 3-in-1 bulb. So it has four pins total, one shared uh, anode or cathode depending on the model. Then each of the pins should have the color. So here is an example or actual example of a RGB bulb. I think you can buy one somewhere for 5 pesos a piece. Let me check. Let me just fix the zooming in. Okay. Okay, this is LED bulb, RGB LED bulb. You will notice that there are four pins in it. So, okay, let me fix the exposure again. Okay. So now we will be using this RGB LED in order to demonstrate analog write. So let's try. Uh, has anybody managed to catch up to my lessons? Because I will be moving the uh, board. Let me know if you manage to are you lag behind, ha, so that I will be returning this back. So let's stop the simulation for a bit and hide the code. Now we will be using the RGB bulb. So let's try putting the RGB LED here. Then you will notice that each fit has a corresponding function. For example, this one is red, this one is cathode, and this one is blue and green. So cathode should be connected to the ground. So we will be connecting this to the ground here. Okay, and assign the color black to it. Now, uh, let's move this up a bit further. Maybe here. Then let's put another wire here just to bridge the gap. Okay. Then we'll be re-adding the resistors. So we can just copy the resistor here. Click the resistor, then copy, then paste. Again, copy and paste, and another paste. Okay. So now we have three resistors, each for the corresponding color. Now we will be using the PWM pins. So this is important for analog write. You can only use analog write in the PWM pins. Again, PWM is indicated by the tilde, which is 11, 10, 9, 6, 5, and 3. So we will be using 11, 10, and 9 for this. So this is color red. We will be using red here. Let's just try here in pin 11 and assign the color red. Then what color is this? Blue. We'll be using blue. So put it here and change the color to blue. Then this one is green. We will be using a green wire for this. Okay. So now that we have uh, connected our RGB LED, we will be trying to put or we will try to put code in it. So first, we are going to disable our previous code. I want you to disable it. To disable it, we are going to change its form into a comment. So you can do this by adding two slashes, two, 1, 2, 1, 2. Then do it for the others as well. Now we have disabled the code, meaning that it cannot interfere anymore with whatever we are doing or what we are currently doing at the moment. Then let's try changing the pins here. So the pins that we used here are for red. For red, it should be 11, blue is 10, then 9 is green. So 11 is red, green is 9, and blue is 10. So we don't have to change the void setup anymore. Now, we are going to type analog write. So the main difference between analog write is that analog write actually allows you to create values that are in between high and low. So you can simulate fading effects using this. So if you can see your mouse or you have an RGB mouse that is fading in and out, it is actually using the signal analog right. So for those that oriented with the syntax of analog right, let me show this to you. So the syntax of analog right, as documented by Arduino here, it is capable of uh, actually receiving the values in number from 0 to 255. So here in our sketch, you will read here, there is high and low. So high should be 1 and low should be 0, right? So you will notice here in the parameters, if we put 0, it means low. And 255 means high. But you can also put any kinds of number in between. It could be 100, it could be 150, it could be 255. If you want to simulate um, something like that, then it should be possible. So let's say, um, so you can see here how it is being used. So let's go back to our code here. So first we're going to call the pin. So let's try this first with red. Pin red. Then comma, then the value. The number should be either 0 up to 255. So let's try uh, a differing phases between the colors. So um, let's start with 0, then let's add a delay. Let's say we will add a delay of 25. Or maybe it is too small. Maybe let's make it 100 instead. 100 milliseconds. Then let's copy this. Then we will be adding by increments of, let's say, 20. So 20, 40, 60, 80, 100 until we almost reach 255. So let's just say we will increase the intensity here, 140, 180. So let's try running the code. So as you notice, it is trying to simulate a fading in, right? It is trying to simulate a fading in. So I will try to recreate the same or the similar pattern in actual. So you will actually see the difference. So let me dim the light of my room a bit so that you will notice the difference. Wait, let me turn off the lighting of my room. Okay, let me adjust the lighting of my room a bit. Okay. Now I just made my room a bit dimmer. So now, uh, as you can see, the light is a little more brighter, right? We will try to copy the code that I made here and apply it to my Arduino. Let's try applying this. Let's put it here. Wait. Uh, I can only apply this to green because green is a because 12. Okay, I can use green or blue. So I will be using blue instead. So let's simulate the effect with blue. Blue. Okay, let's try this. As you will notice, it is currently pulsating. It is due to the use of analog write. If you want to fade it out, you will just have to copy this code and reverse it. So let's just try creating a fade in and fade out effect in it. So let's just add a little bit more code. Let me hide my camera, or rather, let me just uh, there. Then, as you can see, I am reversing everything back to 0. Then 140, 80, then 60, then 40, then 0 to recreate a pulsating uh, effect. You can achieve a better efficiency pulsating effect or fade in fade out effect if you use functions such as for loop for this. You can actually achieve better performance with using for loop. But for simplicity's sake, I will be just doing something like this. You will notice, right, that it is fading in and fading out. I didn't even complete the whole uh, the whole scheme. So any questions regarding uh digital write and analog write?
So far na po, sir.
So how about mixing in different colors? We will try mixing in different colors this time. So let's say here in our example here in Tinkercad, let's try enabling other colors. So we can make it so that uh let's stop the simulation first. We can make it so that uh, it runs with different colors simultaneously. So let's just try this one for blue. So let's just do this with a different pattern. Let's say 40, 6, 8, 80, 120, then 160. Let's try this. So as you can see, it changes its color. We can even make use of the green here. Let's just switch things up to make this green in this side instead. Let's say with green, we started off with 80, then 160, then 40. As you can see, it changes colors differently, right? So this is how RGB LED bulbs work. It's actually just a manipulation of the differing colors between inside the RGB bulb. So again, as a proof of concept, I will be copying the code and posting it here in our actual Arduino. So pin red, we will be changing this to pin red instead. Pin green and pin blue. Pin blue, pin green, and pin red. Now, because some of some of the wires are actually are not in PWM, specifically red, we will be disabling red and changing it to green instead. So let's just switch this to green instead because it is not a PWM pin. Pin 12 is not PWM. So let's just change this to green. Now let's try running this again. So because this only involves two colors, it is not much it doesn't really actually feel like there's changed colors. But it would be noticeable if you are using three PWM pins at the same time, similar to the one that we are currently demonstrating here in our Tinkercad. So that's all for our discussion today, which is actually focusing more on analog right and digital right.